Unit 6, Day 3, Triangle Inequalities. The triangle inequality theorem 1 states that if one side of a triangle is longer than another side, then the angle opposite the longer side is larger than the angle opposite the shorter side. So we have the side AB that's labeled with 3, and BC is measured 5. Since 5 is longer than 3, that means the angle opposite from the side measured 5 is going to be greater than the angle opposite the side measured 3. So therefore, the measure of angle A is going to be greater than the measure of angle C. Triangle inequality theorem number 2 states that if one angle of a triangle is larger than another angle, then the side opposite the larger angle is longer than the side opposite the smaller angle. So here we have this angle measure of 60 is greater than this angle measure of 40. Therefore, the side that's opposite from the angle measured 60, EF, is going to be longer than the side opposite from the angle measured 40, which is going to be DF. So we have here segment EF is greater than segment DF. Here are just some examples of problems that we can have given these two theorems. This one, we're given a triangle with two angles, and we need to list the sides in order from shortest to longest. Now, in order to do that, we need to know the measures of all three angles. So the first thing we're going to do is find this missing angle that we don't know. Now, we've all learned before that the three angles in a triangle have to add up to 180. So if we take 180 and then we subtract 61 and 48, then we're left with 71 degrees. Okay. So we have 71 degrees, 61, and 48. Now we want to go from shortest to longest. So that means the smallest angle, 48, is going to be opposite from the shortest side. That's side DF. Then we have the medium-sized angle, 61, is going to be opposite from the medium length side, EF. Then lastly, we have the largest angle, 71, is going to be opposite from the longest side, DE. When we look at this bottom example, it wants us to list the angles in order from smallest to largest. So we're given the side lengths 4, 7, and 8, and we need to list the sides from smallest to largest. So since side 4, this length is the shortest, that means it's going to be opposite from the smallest angle. So angle C is going to be the smallest. Then side 7 is the medium length side, and that's going to be opposite from the medium-sized angle, angle B. And then lastly, the side measuring 8 is the longest, so that's opposite from the largest angle, angle A. So my pen seems to be a little glitchy again this time, so kind of bear with me. I know the handwriting is a little messy. The exterior angle inequality theorem says that the measure of an exterior angle of a triangle is greater than the measure of either of the two non-adjacent interior angles. So remember, in Unit 4 we talked about how the measure of angle 1 is equal to the measure of angle A plus the measure of angle B. So since 1 has to equal A plus B, we can say separately that 1 is definitely bigger than A, and angle 1 is definitely bigger than the measure of angle B. The triangle inequality theorem 3 tells us that the sum of the length of any two sides of a triangle is greater than the length of the third side. So that means that if we were to take side AB and add it to BC, that's going to be longer than the side AC. if you were to take BC and AC and add them, it'll be greater than side AB. If you take AB and AC and you add them, it has to be greater than side length BC. Otherwise, the three side lengths cannot make a triangle. So these are two different types of examples that we can work out using that theorem number 3. In this first set of problems, it tells us that 3 segment lengths are given, and we need to determine whether these segments can make a triangle. Now, based off of the triangle inequality theorem 3, each 2 sides has to add up to greater than the third one. So the question is 4 plus 7 equals 11, and that is greater than 6, so that works. 7 plus 6 equals 13, which is greater than 4. Now if you add the first and the last, 4 plus 6, that equals 10, which is bigger than 7. Therefore, this makes a triangle. Those 3 sides can make a triangle. When you look at the next 3 sets, a faster way to get through this is if you actually just analyze the 2 shortest sides. So forget about 11, because 5 plus 11 is 16, which is definitely greater than 3. 3 plus 11 is 14, which is definitely greater than 5. So if you just check the 2 smallest ones, 5 plus 3 equals 8. Now 8 is not bigger than 11. Therefore, these sides cannot make a triangle. Okay. So again, we're going to take this one and just take the 2 smallest ones, and then we're going to add those together. 8 plus 4, and that gives us 12. 12, it cannot equal the third side. It has to be greater. So since 12 is not bigger than 12, again, our answer is no, these 3 side lengths cannot make a triangle. This bottom example tells us that 2 sides of a triangle are given, and we need to describe the possible lengths of the third side. So we know one side is 2 inches and one side is 5 inches. So we need to know the biggest and smallest number that third side could be. So we're going to take the 2 most basic operations we've learned. 2 plus 5 equals 7, and then 5 minus 2 equals 3. Now we're going to take those 2 numbers and set up an inequality. 3 is less than x is less than 7. That means that our third side has to be between 3 and 7. It can't equal 3 and it can't equal 7, but it can be any of the numbers in between it. The Hinge theorem says that if 2 sides of one triangle are congruent to 2 sides of another triangle, so we have RS congruent to VW and ST congruent to WX, and then the included angle, this one that's measured 100 degrees, is greater than this angle that's measured 80 degrees, then the third side of the triangle, this one that's opposite from the 100 degree, is going to be longer than this side, the side that's opposite from the 80 degree. The converse of the Hinge theorem is the same idea, but just the opposite. If we have those same 2 sides, AB congruent to ED, and then we have side AC congruent to DF, but then you're given that third side length. BC is 8, which is greater than EF, which is 7. That means that angle that's opposite from the side measured 8 is going to be greater than the angle that's opposite from the side measured 7. Now, when we get to these types of problems, we just need to fill in the blank with either less than, greater than, or equals. So we're going to analyze. This is saying we're comparing segment AB with DE. So that means we're comparing segment AB with segment DE. So in order to compare those two, what we're going to be looking at is the fact that we have this side is congruent to this one, and then this side is congruent to that one. So we want to look at the angles between them. This one is 110, which is greater than 105. That means that the segment that's opposite from 110, DE, this is going to be greater than AB. So we need our symbol to be facing this way so that DE is greater. Same idea over here. We are actually comparing in here the measure of angle 1 with the measure of angle 2. So here we have the measure of angle 1 compared to the measure of angle 2, and we need to know which one's greater, smaller, or are they equal. So we look at the information we have. This side is congruent to that one, and this adjacent side is congruent to itself. So we use the opposite sides from the angles to compare. This side is opposite from angle 1, and this side is opposite from angle 2. So when you compare those two, this is 6, but this is also 6. That means that angle 1 and angle 2 are actually going to be equal to each other. That's all. Make sure you study, and I'll see you next class.